Okay, so in an ROL circuit, it therefore means that we are removing the capacitor. So this is going to contain a resistor and an inductor. I just want to draw the circuit. Everything would look like the other one. We just have to what? So we have the VRMS voltage and the frequency in hertz. Okay, now this is what you should notice here. So this is what you're going to notice. The voltage. Remember that for an RLC circuit, the voltage is equal to square root of VR squared plus VL minus VC all squared. So if there's no capacitor there, this becomes, so you see this will be just reduced to V arrow square plus VL. And if you apply this to a capacitive circuit only, that's an ROC circuit, series circuit. For an ROC series circuit, this is what you are going to have. It's going to look like this. So you're going to have a capacitor, a resistor. Then you have a capacitor. So in this case now, you find out that this guy becomes 0 and the square of a minus becomes plus. So the voltage in the circuit becomes V is equals to square root of V arrow plus VC squared. And again, before I omit that, just going to have the phasor. So this time around, the phasor is going to be equal to arctan VC over V arrow. Then for the other one, the phase difference is going to be equal to arctan VL over V arrow. So in a nutshell, you can now see that what I just did was to remove one of the variables that is not available from this equation. Okay, now if it is an LC circuit, so it means that we're going to have an inductor and a capacitor only. Inductor, capacitor. Then you have this, the voltage, the frequency. Now you notice that in this case, V arrow is going to be equal to what? 0. So if V arrow is equal to square, you're going to have V squared is equal to VL minus VC all squared. Notice that this will cancel out this. So the voltage will just be equal to VL minus VC. And the phase difference is just going to be 180 degrees. So there will be 180 degrees out of phase. It's very simple. When you look at this, the circuit like the phasor diagram like this is VL and this is VC. So the angle between them is just what? 180 degrees. 180 degrees or pi radians. So 180 degrees is pi radians. Okay. So that's the phase angle between difference between them. Now the next thing I have to look at, we can also derive this, use this circuit to derive the impedance of the circuit by, instead of using the voltages. So to get the impedance, I'll go back to the RLC circuit. So the impedance of this Z. I will not go into trying to prove how we got the impedance. I will just derive the formulas because of the length of the video. So Z for RLC circuit, Z is going to be equal to the square root of R square, now the resistance itself, plus XL minus LC all squared. So you see that in terms of this, now this is the reactance of the inductor, and this is the reactance of what? The capacitor. And the phase difference will be equal to arctan XL minus XC divided by R. Okay, let me just draw the Phasor diagram in terms of impedance. So this is going to be XL again. That's the capacitive, the inductive reactance, and this will be the capacitive reactance, and that this will be the what? The resistance. So you see that this is also on a straight line. So you're going to have XL minus XC. Okay, so this will reduce to XL minus XC. Then we have arrow this way. So if I draw this, if I complete a square or a rectangle for this, I'm going to have this way. So this is the impedance, and this is the Phasor what? The phase difference. Okay, so if you work this out, this is going to be XL minus XC. So you can see that this also holds for what we did before. Now, if it is just an, let's say, RLC circuit, so RL circuit, let's start with an RL circuit. For an RL series circuit, then you know that XC is going to be equal to 0. So Z is going to be equal to the square root of R squared plus XL squared. For RLC circuit, you know that XL is going to be equal to 0. So Z will be equal to the square root of R squared plus XC squared. Okay. Now, if the circuit is simply LC series circuit, then this arrow will be equal to 0. So the impedance would simply be equal to XL minus what? XC. That will be the impedance. Okay. So next, we are going to take examples on what we have done here. Okay. But by the time we take some example, if there are some explanation that I've omitted, I'm going to use the examples to work those ones out.